Hi, in this video I'll show you how to divide complex numbers. So suppose if I have 3 over 6 minus 5i. Now you can see that I have an imaginary number in the denominator. Now can you divide a real number by an imaginary number? No, you can't do that. If we go back and look at this example, 1 over root 2, how do we solve it? Since we have the irrational number in the denominator, you can't divide a real number with an irrational number. Well, it doesn't make any sense to divide a number with another number which just goes on forever, which is never ending. So you can't divide it. So what we do is we get rid of square root of 2 from here. So we just multiplied that by square root of 2 in the numerator and denominator, and root 2 times root 2 will give me 2, and 1 times root 2 will be root 2. So you can see that finally we got rid of the irrational number from the denominator. The same thing we'll do here. Now this time we don't have an irrational number, but we have an imaginary number, and we want to get rid of it. So what we're gonna do is we'll multiply this binomial with its conjugate. So let's take a look at this example. Suppose if I have 5 minus I. Now what will be the conjugate of this binomial? I want to get rid of the imaginary number. So what is the conjugate? So conjugate of 5 minus I will be 5 plus I. This means that conjugate is the exact same binomial with the exact same terms, but with the opposite signs. You can see the signs are opposite, but the terms are exactly the same. So how do we get rid of the imaginary number is we multiply the binomial with its conjugate to get rid of the imaginary number. And when you do that, you'll get a real number. We'll see how do we get that. So we just FOIL it. 5 times 5 will give me 25. And then 5 times positive I will give me positive 5i. Negative I times 5 will give me negative 5i. And then negative I times positive I will give me negative I squared. You just multiply 5 with this, and then again 5 with this. And then the next time you multiply negative I with 5, and then negative I with positive I. Now here you can see that positive 5 and negative 5, they cancel out each other. So you're only left with 25 minus I squared. Now we know that the value of I squared is negative 1. We'll plug in the value here. So we'll get 25 minus, since I squared is negative 1, I'll just write negative 1 here. Now 25, you can assume that this is negative 1. Negative 1 times negative 1 will be positive 1. So I'll get positive 1 here. And 25 plus 1 is 26. Now what do you notice here? That when you multiply a binomial with its conjugate, you end up with a real number. So you got rid of the imaginary number. The same thing we'll do here to get rid of the imaginary number, since we can't divide a real number with an imaginary number. So we'll multiply 6 minus 5y with its conjugate, and let's do it together. So again, the conjugate is exactly the same binomial with the exact same terms, but with the opposite signs. So take the same terms, but with the opposite signs. So I will multiply this by 6 plus 5i. In the denominator and then the numerator. So you can see that I have multiplied that in the numerator and denominator because I don't want to change the value of this fraction. So that's why you have to multiply numerator and denominator. Now how to solve it is you just use the distributive property, multiply 3 inside the parentheses. So 3 times 6 will give me 18. And then I have 3 times positive 5i will give me positive 15i. So I have got 15i. Now, it's okay to have an imaginary number in the numerator, but it's not okay to have an imaginary number in the denominator. That's why we rationalized here, and that's why we had to multiply with its conjugate. So now here, I will tell you a trick to multiply these two numbers. If you remember that we know that the difference of the two squares, we have learned that a plus b times a minus b is equal to a squared minus b squared. Now we know that the difference of the two squares, when do you get that? If you have a square term subtracted by another square term, then you can rewrite them as a product of a plus b and a minus b. So this is what we got here. If you see this 25 minus I squared, so 25 is, you can see that this is our a, this is our b, a minus b, and then a plus b. Whenever you have a square number subtracted by another square term, you can write that as a product of two binomials, a plus b and a minus b. So the same thing we can do here is when we have this here, 6 minus 5 and 6 plus 5i. So we have the same thing here, and we can write that as a difference of two squares. Well, you can multiply each and every term. You can just FOIL it and solve it, and you can do that method. But it's just a waste of time. If you know this property, you can write that directly. But I will go over, I will just multiply, FOIL it, and I'll show you how do we get the same answer. So let's multiply this. 6 times 6 will give me 36. And then 6 times positive I will give me positive 30i. And then negative 5i times 6 will give me negative 30i. And then negative 5i times positive 5i will give me negative 25i squared, since 5 times 5 is 25. So in the numerator, I have 18 plus 15i. And in the denominator, I have all these things. So you can see that positive 30i and negative 30i will cancel out each other. Well, that will happen always. If you see that if the two terms are the same and only the signs are opposite, then you can just write them as the difference of the two squares, but they have to be the perfect squares. So this will happen whenever you multiply a binomial with its conjugate. It will happen always. So you can just write this as a squared minus b squared directly. So if suppose this is your a and this is your b, so you can write that as a squared minus b squared. So a squared is 6 squared, which is 36, which is what you got here. And then b squared is 5i, 5 times 5 will give you 25, and I squared, so 25i squared. So you'll get negative 25i squared. So this is a squared minus b squared. So you will get the same thing. You can either use this property to solve it, or you can just multiply FOIL if you're more comfortable and cancel out the like terms. So now we have here 36 minus 25i squared. And I can write this as, I just have to plug in the value of I squared here. So I have 18 plus 15i over 36. Then I have to plug in the value of I squared here. I squared is negative 1. So I will substitute here negative 1. And I have 18 plus 15i in the numerator. And then in the denominator, I have 36. Now, negative 25 times negative 1 will give me positive 25. So I will have positive 25 here. And you can see that I've got the real numbers in the denominator. That is the purpose of the conjugate, is you get rid of the imaginary number from the denominator. So now my final answer will be, well, I can write the final answer here. 18 plus 15i over 36 plus 25 will be 61. So this is my final answer. I can write this, I can break it. I can separate the terms. I can write this as 18 over 61. Now I can't reduce it anymore since 61 is a prime number, plus 15i over 61. Or I can leave it like this. Both the answers are correct. Thank you for watching this video. See you in the next video.